Very true.
So we have to know what parts are likely to fail and what the failure modes are, what's going to cause those failure modes. And the only way to figure that out is to break it.
Well, thanks for sharing that with us. That's kind of cool.
It's kind of SpaceX philosophy, isn't it, Danny?
Yeah, rapid iteration and destructive testing. One of the things I do in my day job is I run a pressure simulation test facility. And
Okay.
what that is we simulate full ocean depth pressure. So we take the instruments like that data logger that we just deployed, and we'll stick them in a tank and pressurize them to the pressures that we are going to see them subject to in deployment.
Mm-hmm.
And we do that in a controlled environment with data connection, so we can make sure that the data logger is reading everything correctly. We're getting the measurements we want in a simulated ocean environment.
Neat.
I still find it interesting that the pressure monitors that we've recently installed inside of several of our titanium enclosures actually change as we descend and ascend. I still don't see how that, I can't get my head around it.
Even though it's in a titanium tube, the titanium does squeeze.
Enough to change the pressure inside the bottle.
Yeah.
That a $15 instrument is monitoring and sending us data.
Because as we ascend, the pressure goes down. As we descend, pressure comes up.
Yeah, but it's getting more pressure as we come up.
Should be the other way around.
Yeah, so I can't get my head around. I think it's temperature.
Could very well be temperature.
So the air is colder, so it's less dense. Or it compresses because it's colder.
Well, it does bring to mind the question when you're testing, these things to failure. Do you have these moments of, that wasn't supposed to do that?
Totally.
Oh, definitely.
Have you got any particularly memorable ones?
Yeah, I had this junior engineer that was designing a protective cap for the bearings on a manipulator. And I felt really bad, but I would make them cry. Like they would spend days re-engineering the part, and I'd break it in about 30 to 60 seconds.
Mm.
And usually it's a really good feeling when you're like, yeah, I figured out a problem with that particular design. But it's really heartbreaking to see somebody put so much time and effort in something, and then you could break it in like 30 seconds.
Mm-hmm.
Mm-hmm. Danny, how about you?
I've been doing a kind of a side study on using 3D printed parts in the ocean
Mm-hmm.
and taking them to depth and how they react to the pressures and temperatures at depth. And so I've been printing cylinders and different shapes and sizes of different infills, different kind of thicknesses, different materials, and I've been subjecting them to ocean pressures to see how they react.
I see. Is it any exciting findings so far? Or unexpected findings?
Not super unexpected, because I guess it's easy for me because I know what to expect, but for the untrained eye, I shove a bunch of plastic into a pressure housing and pressurize it, and see what happens.
I was
And
very surprised that the hollow parts didn't implode.
because the plastics are extremely porous, so the water just kind of penetrates the part and equalizes.
Hmm.
I would have thought they would have looked like those styrofoam cups that we always take down.
That's always fun to do too. That's a great experiment.
For those who aren't aware, the styrofoam, when you take it down to depth, it crushes the little beads back to their kind of quote-unquote original size. So you get these styrofoam cups that start out, big and fluffy, for lack of a better word, and then they come back and they're small and crunchy.
Size of a thimble or a shot glass.
Yeah, shot glass.
Now, Video, do you push your equipment to breaking, or is there different protocols?
Definitely different protocols, I think, for these cameras. We definitely don't want them to break. And in general, I don't like when my underwater housings leak.
Very fair. How about nav? Do you test to breaking?
I can't think of anything that we...
I can. Lynette's broke the ship I don't know how many times.
Oh.
So many times. Just the entire ship.
Yeah. There's a big duct tape line down the middle of the whole ship,
Exactly.
actually, holding the two
Maybe.
pieces together.
Maybe not Lynette in particular, but several navigators have broken the ship.
Could you elaborate? How does a navigator break a ship?
They ask it to do something it can't do.
Oh.
Like, go sideways at 2 knots into a 30-knot wind.
Ah, I see. So I guess moral of the story is if you're going to break something, make sure you have permission to break it first.
Yeah. Gets rather exciting,
That is true.
especially with 2 ROVs dangling at 3,000 meters.
Yeah, you do want to kind of have an idea of how your equipment's going to behave at that depth.
We actually had to have a meeting with the captain to train us all up on what the ship can and cannot do.
That's got to be good information to have.
Yeah.
Sideways at 2 knots. That's a into the wind. That's a cannot do.
Yeah, we have some parameters on, depending on weather and current, the ship can move forward or backwards, or say at 30-degree angle, and it obviously has to maintain its heading. Otherwise, if it doesn't maintain a weather heading, it can't hold station because it's then sideways into the weather. And so when we ask for a vessel move, we have to be conscious of that. And when the ROV is dangling next to a cliff or a chimney at Endeavour, structure at Endeavour, and we're pushing the weather envelope, it limits us to how we can move the ship. And if we try to do something it can't do, the DP will basically go into an error state and it has to be reset. And during that 30 seconds or so, it can be quite exciting.
Well, it's a good reminder that we may not see it on the cameras per se, but there's always a ton of forces acting on us and the robots and the ship and everything. And the ocean is hugely powerful. So, maintaining our heading, being in the right spot, that all takes opposing forces working together. It's a neat jelly we got floating around in front of us.
Yeah. Tina 4?
I don't think so.
No.
It's actually maybe a great note to leverage off of the conversation here. Oh, look at that one. Maybe it's the same one. A lot of the equipment that Ocean Networks Canada's deploying is rigorously tested at our technology enterprise facility before we deploy it as well. So we've got those saltwater tanks, we've got all sorts of other equipment so that we can test it and make sure that it's kind of ready for graduation day when it gets deployed.
Do they test stuff to destruction?
That's not something I can answer, actually. I would assume that they test things to make sure that they're going to be ready, which probably sometimes includes destruction.
I know we've destroyed a few of their instruments. Not on purpose, of course, but
No, of course not.
we were testing.
I'm curious if they have a pressure simulation facility.
They do. There's a really excellent pressure test facility in BC.
Yeah.
Yeah. I don't know if ONC has one. I know there's one there at iOS, or there used to be.
We don't have one in-house, but we will often, for some of our smaller instruments, we'll use one at our friends at AML. They have one for all their CTDs, and given our working relationship, they often let us use it for critical instrumentation.
Are they the commercial outfit that
Yep.
does? Yeah,
Yeah,
they
they
have a
do,
nice facility.
Yeah, I haven't been actually, but they do all the, well, I shouldn't say all the shallow water CTDs, but we use a lot of their CTDs in shallow water.
So the chamber I operate is 24-inch in diameter and 12 feet deep, and it can handle 10,000 psi.
And how does it do that? How does it add how do you add more pressure?
We have what's called a positive displacement pump.
Okay.
So what we do is we compress the water.
Okay.
And I know I'll get a lot of people being like, well, you can't compress water, but you can. It's very micro compressible. So what we do is we fill the chamber up with water until there was absolutely no air left in it, and then we push in more water.
And you just keep doing that till your pressure builds.
Yep.
Neat.
And Danny's tested 3-4 of the bottles that are currently on Herc in that particular chamber.
The Ethernet bottle, the camera, the two new stereo cameras.
So if they pass testing, do they go on the equipment? You don't test an identical one and then put a new one on the equipment, is that right?
No, we test the actual unit that's going to be dove.
Okay.
So it's a OET requirement to have pressure vessels certified before they go on the ROV, because if they fail catastrophically, they can take out other instruments on the ROV.
That does make sense.
So yes, last year they had what was called the light sun sphere.
Yeah.
It was a 17-inch diameter glass sphere full of LED lights. And we tested that at the facility in Hawaii to certify it to go on Herc.
And do you ever look at them like under a microscope for micro cracks, or?
We pretty much, if it doesn't flood and it's dry inside, then we are happy with it.
Okay, neat. Neat. Well, and again, I appreciate you sharing all this info with me. It's a new experience for me, and sharing your insights with our viewers.
Of course, no problem at all.
Do you ever put anything in the chamber just to see? Like, have you ever put a gummy bear in the pressure?
I have thrown a couple steaks in there.
Oh, please tell me more. Tell me more. You put some steaks in there. I want to hear about this.
So I basically put some steaks in a marinade,
Mm-hmm.
vacuum sealed them, and threw them in the chamber.
And what happened?
It marinated them. It was actually extremely tender afterwards.
Hmm.
You cooked them up after that
I did.
and then ate them.
I did.
Huh.
They were vacuum sealed.
So they're vacuum sealed, and then you brought them up to pressure. So the thinking being that it would drive the stuff, the marinade, into the fibers of the meat,
Exactly.
tenderize it. How long does that take?
I mean, I was just doing a standard pressure test, so it was only about 8 minutes.
Okay, interesting. Hey, maybe that'll be the next big food trend.
Instant marinade.
Yeah.
It was.
Can I interest you in this pressurized Chateaubriand?
Took it up to 8,000 PSI.
Huh.
And then I do styrofoam all the time. We do the styrofoam cups for the kids.
Mm-hmm.
I've done them for several groups of kids. That's kind of common. Prototype housings, so fun to put in there because they don't always come back out in one piece.
Now, and what do you hear it? Does it make a big sound when it fails, or
It
does
sounds like a metal wrench on the side of a tank, just like a tink.
Dink. Okay, and that's the sign that it's failed.
That's the sign of you're gonna have a bad day.
All right, good to know.
Some engineer's going to cry.
Yeah, exactly. Or a machinist.
Or a machinist, because you got to make another one.
I don't know. I sometimes I think the creating of the thing is the fun part.
It is.
You know.
A lot of these housings that I test, I'm actually the sole person to make them out of a solid chunk of titanium. So we use an alloy called 6Al4V titanium alloy. And that is what we build our pressure housings out of. That way they're not, the corrosion, they can't be attacked by corrosion. They're virtually indestructible. And don't weigh a ton. So with 6Al4V titanium housing, say for instance, one of the housings I've designed was 8 inch in diameter, and the ID was 7 inch, which means I had a 1 inch wall. Total thickness, 1 inch, so it's half-inch wall thickness.
Mm-hmm.
And it could handle 8,100 PSI.
Neat.
Which is more than Hercules can handle.
I guess there's a point where you only have to be as good as literally the guy next to you.
Well, Hercules is designed to go up to 4,000 meters. And there are several pieces of equipment on Hercules that can go deeper, but
Most of it, actually.
I think the only thing limiting us is our foam in the main bottle, right?
Yep. Pretty much.
And is that something that would ever be swapped out, or is that something that is kind of integral to Herc?
The issue with that is if we did swap it out, we would need a bigger crane to launch and recover it. So we're pushing the envelope there on Hercules weight.
Also having that much weight,
we have.
having that much weight on the end of the cable, having that much cable out, it's gonna be pushing the limits on the A-frame.
It never sees it because it floats. So it's just, you know, once it's in the water, it's mutually buoyant.
Okay.
It's just getting on and off the deck. The launch and recovery, especially during weather.
And I've got some very helpful comments in the chat, which I will sum up, and it's just a friendly reminder that Danny and company are doing this kind of testing under safe and monitored conditions. Please, please, please do not try this at home.
We are professionals.
Exactly. Yeah, we don't want anybody making. Well, we don't want anybody hurting themselves at home.
In the words of Adam Savage and Jane Heineman, please do not try this at home. We are professionals.
Yeah, there you go.
They're usually, well, almost always engineered tests, so they're mostly know what to expect. Like you say, sometimes you get surprised.
We don't want surprises. We want a nice, boring day. Just like with the ROV, we don't want any excitement. The excitement we want is from what we see, not what we have to do.
That is very true. Now, Little Herc goes deeper, yes?
Yeah, it's rated to 6,000 meters, same as Atlanta.
Atlanta, there you go. Now, we've filled up the deck. We've used up a lot. Ocean Athletics, has used up a lot of the deck. Do Herc and Little Herc ever travel together?
Usually, yeah. Usually
Okay.
we have Little Herc taking up
Neat.
a little corner of the deck there. It's currently taking up space in one of Danny's hangars at UH.
Neat. Got some folks in the chat who are actually curious about the sealing of the pressure vessel. Is it a threaded connection with O-rings?
So, funny thing is, one of my pressure vessels is a repurposed bullet from an Ohio-class battleship.
Go on.
So the 16-inch cannons on the front of a Ohio-class battleship, like the Missouri, they repurposed one of the projectiles to be a pressure test vessel back in the 1960s.
Pretty common one, actually. We had one showing too.
Oh no,
Exact same one.
Bentos built hundreds of them.
Yeah.
Neat.
And it has threads, but the chamber is basically designed to amplify an explosion, and we use it to test for full ocean depth. And the other chamber I operate uses what's called keys. So it's a cork, essentially. It drops into the top of the lid, into the chamber, and then we have keys that slide into these slots to seal the top of the chamber.
Cool. And I see we've got some more questions about Herc and Little Herc, so I'm gonna bundle them for you and send them your way. So let me bundle it up here. With the winch cable, when it's being brought back on board, it's being wound. Is it cleaned before it does that, or is it just going right on the winch from the seawater?
We do have a overboarding wash down system that's plumbed up to the A-frame that you see there, the overboarding sheath. And we don't use it every single time. We typically use it on the deepest dive of the expedition.
Cool. And will Little Herc be used this season, do you think?
Good question. Above my pay grade.
Pardon me? Above your pay grade?
Yeah.
Yeah, okay, well, there you go. Then clearly way above mine as well.
Hopefully we'll get to use it. That's.
How long does it take to swap them? So let's say you're out somewhere, and now again, we do make maps before we go, and it's unlikely that you'd say find a surprise trench. But if you did a Herc dive, and then you decided, no, we want to go deeper, we need Little Herc, how long would it take to swap them out?
We do often swap them. It's, I think our published time is 4 hours, maybe 6 hours.
Cool.
The physical swap of them involves lifting the tether off of Atalanta and attaching it, lifting Herc's tether off of Atalanta and attaching Little Herc's tether, but then we also have to go through all the pre-dive checks There's some extra checks that we have to do when we swap a vehicle over that we don't normally do every single time.
And the software is different too, right? So you have to run different software, muxes.
Yeah, we have to swap stuff over here in the control van.
What kind of stuff? Can you tell me more?
Yeah, we have to physically swap computers. So Little Herc has its own dedicated topside control computer. It has the topside interface, what we call the multiplexer, where all the signals come out of the fiber optic cable and get distributed to the tactile controls here at the console, and all the data routing throughout the vessel and all that. The sonars have to get swapped over.
Now, this is going to be a gross oversimplification, but it sounds kind of like switching between PlayStation and Nintendo Switch. Is that close?
Yeah, that's a decent analogy.
Okay, cool.
And all that stuff we swap then has to be tested. And I have to make sure it, falls in the right parameters to be diveable.
Very cool.
So, yeah, I'd say the testing takes almost as long as the physical swap. And then we have to go through the normal pre-dive stuff that we do every time anyways. So that alone is an hour or two. Maybe it's probably closer to...
You gotta install your wide field camera array, don't you?
Yeah, depending on the state of our spares, we have to also move devices from one vehicle to the other. Some of the jewelry on there is fairly expensive. There's $50,000 sonars and $250,000 cameras and stuff like that we don't have just laying around.
That's pretty fair. I have a question come in, whether or not Little Herc ever had manipulators added to it.
Nope.
Nope. Keeping it arm-free.
For now.
We've talked about making a sled for it that has little baby manipulators. But it does get the main Zeus camera, which is apparently been used as a deployment device, as a manipulator. He used to attach some gizmo to it, and then the range of motion on the camera is like 125 degrees, 130 degrees, something like that. So they would rotate it over, and it would basically dump something off, and they would deploy something with Little Hercules that way.
So basically they'd balance it on his head,
Yeah.
get him to turn his head, and fall off, and call that a deployment.
Pretty much, yeah.
Nice. I like that.
I've never seen that done. That's just some rumors from some of the old timers around here.
So allegedly, that's what they would do.
Yeah.
I see. I mean, I guess it kind of comes down to use what you have, right?
Pretty much.
If you're out there and you gotta deploy something through tipping it off the top of his head, why not?
Yeah, there's engineering, and then there's MacGyver.
Hey, you do what works, right? Alrighty, so we are in the last 500 meters or so of our ascent. We are heading back from having worked on the cork this evening. Or this morning, I guess. Having worked on the cork recently. And heading back to the deck of the Nautilus on what is starting out as a very beautiful looking day. Once we recover the ROV, we are going to be doing more deck ops. So we're going to offload sediment traps. Shouldn't say offload, we're going to deploy them. We're going to actually put them where we want them. And those are autonomous vehicles, autonomous instruments that will collect data over the course of a year or more. And then when they're done their, what do we call it? Their year abroad, we collect them, bring them back up, see what they got in them. And again, that's going to clean up some of our deck space so that in later parts of this expedition we can recover other pieces of equipment. And you can have a look at that through the deck cam today. Then it sounds like we're going to move into some multi-beam mapping because the weather has plans, and I think we're along for the ride.
Lynette loves mapping and weather.
I don't believe you.
What's not to love? Data looks great.
Only some minor cleaning needed.
Just minor cleaning.
Can you elaborate on that? What do you mean?
When there's a lot of vessel motion, especially when we're pitching a lot, we get a lot of bubble wash down. So bubbles wash down under the hull, which is where our multi-beam sonar is mounted.
Of course.
And when that happens, we do not get very good data. So the sonar, of course, is an acoustic instrument. It emits a sound pulse, and rather than traveling through the water column to the seafloor, it kind of just sort of bounces around and echoes in those bubbles, and we don't get very good data off the seafloor.
And you have to manually go through and pull out all the not very good data?
Yeah.
Little QA/QC or quality control.
Yeah, exactly.
Post-processing?
Yeah.
Is that must be what they mean when people say, "Oh, we'll fix it in post"?
Something like that. Video might know a little more about that. Fixing something in post. Sounds like more of a video or photography thing.
I know Lynette makes beautiful maps no matter what the weather is. Just has to work a little harder.
I don't know about that.
Well, we've got some more viewers with us, and they're asking about whether or not Herc got any cool upgrades over the season, and also a great reminder here about the daisy chain. Can you tell us what's a daisy chain, and then tell us if we got any upgrades?
We got some very cool upgrades this winter.
Oh, do tell.
But the daisy chain, what is the daisy chain?
Isn't that the series of loops on the rope?
On the tether, it's how we recover Hercules.
Danny could probably do a better job describing the daisy chain. Have you daisy chained lately?
Oh, fish.
No, I haven't. We've been kind of showing up like rock stars.
We've been totally showing up like rock stars.
So for those of us who are unawares, what's a daisy chain, and what's it used for?
So there is a piece of line that is attached to the top of Hercules. And there was a tether that attached to the back of Hercules. Daisy chain is a rope that is attached from Hercules to Atalanta, and it's basically braided around the tether as it's going from both sides of the vehicle.
It's slip knotted.
Slip knot, yes. So when we pull Atalanta on deck through the A-frame, we disconnect the daisy chain, and we basically pull the daisy chain off of the tether and attach it to the crane. And that's how we hook up and lift up Hercules.
And so so you don't put pressure on that tether.
Exactly.
You don't want to lift it.
The tether comes out this back.
Okay.
But let's talk about the upgrades.
Yeah, you took the words right out of my mouth, my friend. Let's talk about them upgrades.
One of the bigger upgrades we did is we got a new left arm. We have a Schilling Robotics Orion 7-function arm.
Okay.
And that, as you saw in the dive earlier, was extremely useful today. Then we did a bunch of electronics upgrades. We got camera upgrades. Instrumentation.
Now, with arms, I've only ever seen 2 used. Are there ROVs that have 3, 4?
Most do 2.
Most are 2? No ROV millipedes?
Dan might have a better idea on that one.
Sorry, what was that? I was
Just
listening
wondering
to that.
if so that I've always seen 2 arms on an ROV, and I'm wondering, are there ROVs that have more than 2 arms?
Yeah, certainly, yeah.
And what might those be used for?
A lot of times there's like a third arm in the middle, and it has usually some specialized task. Could be a suction cutter, could be a chainsaw, could be some kind of special tooling that is meant for a very specific task. I could talk.
It's early. It's early. Cool. I guess you could design one that looks like a spider. Have an arm for everything.
Yeah. Usually the third one is only put on to do it's like a dive specific or job specific task. One of the ones we've used in the past is a suction cup arm. So the ROV was being deployed in the center of a giant cement structure that is a base of a offshore platform. And we were doing work in that because it's flooded. It's like 30 meters across. And so the ROV needed a way to hold itself on, so it would go down there and the suction cup would suction onto one of the tendons, and then we'd have both arms to do repair work.
That's pretty cool. Because, of course, when you're down there, you got all those forces. When you push on something, it can push you back.
Indeed.
Yeah, see it.
There's actually, ROV is quite complicated in that way. You have a 6 degree of freedom
Right.
vehicle, like an airplane or a boat, but then you also have a manipulator with 6 degrees of freedom. And you have another manipulator with 6 degrees of freedom, and they're all fighting each other. So the math to make them work in harmony actually didn't exist till later this century. Just the processing power to have that processing power downstairs or send all of that data upstairs to be processed. Usually it was the pilot and the co-pilot arguing with each other. You're pushing on me. I'm pushing forward. You hear us talking about that today when, the manipulator's pushing against the solid structure. Pilot's compensating with the thrusters.
Looks like we're almost home. We got about 250 meters to go.
Switching to radio comms. Roger. I'll turn off some lights here and see if we can see the surface yet. Nope.
No, it's still pretty deep.
Not very light out either.
So Dan, walk me through what we're going to do when we get on, so 50 meters, we transfer winch over to deck.
Yeah. Actually playing with the iris there. Let's see a little blue hue there. Yeah, the main thing you want to watch now is, so you should burn into your brain what the ship's heading is and keep a weather eye on the ship moving forward.
Okay.
And because if that goes sideways, that Could be bad for us. And then Atlanta's heading should match minus a little bit of an offset that we have in that particular compass.
Herc's heading is 129,
Yeah,
which is
so-
reciprocal to the ship.
Yeah, basically Herc's heading should be reciprocal to the ship. And then you can tell your distance cross course by your 2 aft cameras or your sonar, because you're going to lose nav here pretty quick. You'll
Okay.
probably lose nav, I don't know, somewhere around 50 meters. But I start looking at both of those, so all the planets should align there. And should be able to tell one without the other by now. Definitely by, 200 meters. You're going to want to probably, you can lock in your auto heading if you want. Now, just in case, you don't need it now because we're streaming forward, but if the ship stops for some reason or we have an excessive tail current.
Yeah, because we want to keep it taut, because we're basically a tagline on Atalanta.
Yeah, but if for some reason we do become loose, then we won't get, tangled up. You won't lose your heading, which I've done before, so.
Okay.
But I'll click that back off once we have a visual on Herc, or I'll go in and out of auto heading usually.
And then you just put it between the goalposts, right?
Yeah, you're not going to know what that is, but the only way you can really judge that is by seeing Hercules behind Atalanta and vice versa. You are going to want to be thrusting forward pretty aggressively, especially the last 10 meters when Atalanta's coming up. So I watch the wire cam there.
Okay.
So you want to be pulling Atalanta away from the ship as we come up through the interface. But then once it touches down on deck, then you want to ease off on your forward way. Otherwise you'll try and pull it back off the deck. And then at some point, Mike's you'll see him hook up the, I'll go back to the launch and recovery salvo so you can see. You'll see him hook up the 2 purple lines onto Atalanta, and he'll ask you to pull it tight to pull taut against those lines.
Okay, and that sets it on position on deck.
Yeah, but you want to wait to do that till he's got those lines attached, because otherwise the tuggers are pulling the Atalanta in and you're trying to pull it back off. So you want to keep it tight so it's not swinging around, but not too tight. So as the ship heaves, there'll be a big load on there. And once Atalanta's secured on deck, then you'll want to keep some tension on there as they pull the daisy chain. But you don't want to be...
I don't want to be ripping it out of hands.
Yeah, any ultraviolence going on is obviously bad. We're pretty calm weather now, so you could probably almost not have any forward way on, just rely on the forward way of the ship. But there's not a one-size-fits-all there, because depending on the current, we could have a tail current, we could have aggressive current on the bow, we could have a sideways current. So you kind of got to play that by ear.
Okay.
But I like to see a nice catenary in the tether versus it slapping really tight. And once we get the daisy chain on, once we get the daisy chain recovered and they have the lift line recovered and on the crane, then you can kind of ease off a little bit. And then depending on the conditions, if they're ideal, like they look like they are today, just keep the vessel on your 6, so as the crane swings around, starts pulling you in, I'll usually come out of heading, change the heading a little bit, and go back in.
And you're just basically just kind of pulling away until you get alongside.
Well, I like to keep the vessel behind Herc, so if things go sideways, I can just give Herc a squirt ahead, and it'll get away from the ship.
Okay.
There's not a lot of authority with the laterals, especially on the surface, but you have some pretty good authority to go forward. So if you're sideways and all of a sudden the jet wash gets you or the current gets you, you can't recover with the laterals. But if the ship is behind you, you can just give it a squirt forward and
So
it'll
just
run away.
keep the tail facing the ship.
Yeah, keep the tail facing the ship. And you can see that in your aft camera. So if that tether's coming off at a wonky angle, you know, you're not facing away. And it makes it easier for the folks on deck too to recover the tether.
Okay.
Sometimes the sun will be in your eyes or you won't be able to see in the deck cameras, so try not to rely on those. Sometimes they get a mind of their own and go for a holiday.
But we lose our sonodyne, right? So
Correct.
so I have to watch compass and just maintain ship heading, opposite ship heading.
Yep, the compass is your friend. The gyro in this case. The other thing you want to keep an eye on is the hydraulic reservoir level. So it's up to 100% now. So if you are really being aggressive with the laterals, the motor will heat up and then the motor will get hot, the hydraulic oil will get hot, start expanding, and we'll get too much pressure in the reservoir.
Okay.
And if that probably won't happen in this weather, it's more of an issue we have.
But you go into bypass, right?
Yeah, you go into bypass and just give a little thrust in bypass and it will circulate the oil through the reservoir and cool it down. Hopefully your co-pilot over here will deal with your lights and all the other jewelry. You won't have to worry about that.
Okay.
You will want to have your bypass page up though, so you can, when they do hook Hercules up, we'll want to be out of bypass as we're coming out of the water, and then we usually, once it's secure against the snubber, then that's when we cut the power.
Okay. No. Yes.
Where are we?
I'll stop at 42.
Yeah, we're all stopped.
Stop at 42 meters. Pitch bridge back deck. Mission to go ahead and recover the ROVs.
That gets me every time. I was watching Herc's depth, not my winch payout.
Yeah.
I'll stop on the winch. Tell him I'll stop on the winch, Lynette. I'll stop on the winch. Ask him to I'll stop.
Ooh.
Give us control again.
Level line fail.
Yeah.
Back deck, are you guys going to be bringing up or
Down. We're going to head back down.
Okay.
Can you give me my Herc, the other?
Dive?
No.
No. What do you want?
Launch and recover. I want to see the alternate winch.
Oh, yeah. Layout. I'll just put it right here.
Anywhere, yeah.
I don't see winch. It is mentioned. Level line decided to run away.
Yeah, it did.
Look at the wrench. It did it on that last wall. You did a pretty.
Deck, control.
Go for back deck.
Can you send someone down to the winch hold and correct the level wind?
Heading down to correct the level wind.
Roger.
Yep. Looks like it might have jumped again before.
Go ahead and have everybody stop touching the control right now.
Roger. Control has hands off the winch.
We are going to go ahead and take control of the winch. We are going to lower it down.
Roger. Deck, control. Deck, control.
This is Jake down here on the deck. Mike's down in the winch hold.
Can you stand by on any winch operations? Dan is on his way down.
We're fine down here. I got it sorted out. I'm just needing some tools.
Roger, I think Dan's on his way down. There he is.
control back deck. We are back in business. If you guys want to run it up and down a little bit from the deck control, then we'll go ahead and call it here good. If I can get 2 meters up from the deck and 2 meters back down.
Roger, you're wanting deck to control it up and down, or us up in the van?
Deck to control it from up and down.
Roger.
Control back deck. Are you guys ready to go ahead and continue coming up?
Control is ready.
Copies. Break, bridge, back deck. Permission to go ahead and retrieve the ROVs.
Charlie to continue.
Thank you, Captain. control back deck. Got an angle on Herc lining up to starboard of the A-frame.
Roger.
Control is outboard of the starboard side of the ship.
Roger.
Control deck, let me know if you guys are able to pull Herc around.
Roger, working on it.
Standing by. Control deck. Yep, have Hercules give a little bit of a pull going forward.
Roger.
Control, back deck, we have Hercules about 10 meters from the transom.
Roger.
Control, deck, can you have Hercules bump forward, please?
Roger, bumping forward.
Control, deck, we have Hercules passing the transom.
Roger.
Control, deck, we have Hercules exiting the water.
Roger.
Hercules is out of the water.
Roger, power is secure.